Okay, today we're doing sketching quadratics in polynomial form. Polynomial form is when we have the ax squared plus bx plus c format, so it'll be written like that. And we need to remember back that we can find x at the turning point. So the turning point, I mean when we have our graph and we have the quadratic parabola, the turning point, we can find the x value there using this formula for x. So we know at the turning point, that's where we have the axis of symmetry, meaning both sides mirror each other from the line down there. So that x equals, when you find the turning point, is known as the equation of axis of symmetry. So you may get asked to find the equation of axis of symmetry. So that means you're finding the turning point equation. Okay, so now we're going to do some examples. So we're going to be, in the next couple of examples, going to be asked to find the X and Y intercepts and the turning point of the following equations. And then we're going to be asked to sketch them. So let's do that. Okay, so the first example here, we've got y equals x squared minus 4x. So we are going to find the y-intercepts first. And the y-intercept, as we know, is when x equals 0. So into that equation, if we put x equals 0, so we'd have 0 squared minus 4 times 0, so that y equals 0. So we have the x and probably one of the y x-intercept and a y-intercept at the coordinates 0, 0. So because when x equals 0, y equals 0, there's a coordinate. So if we were thinking of quickly of the graph, it's going through the 0, 0 is one of the intercepts. Okay, so now we're going to find the x-intercepts. Okay, the x-intercept is when y equals 0. So if we put y equals 0 up into that equation, we have it looking like that. So this is a quadratic equation, and we already have one side equaling 0. So we know to solve a quadratic equation, we factorize. So what's common here is x, so I'll take x out of the brackets, and I'm left with x minus 4. So the Null Factor Law states I can let each of those factors equal 0. So we've got x equals 0 or x equals 4. So this is good because we knew that x0 was a intercept from up here. So now we've got the other one. So we have one at 0, 0 here, and then we've got one at 4, 4. So our quadratic, it is a positive quadratic, so it's a happy face, so it's doing something like that at the moment. So the last thing we need to get is that turning point here. So we're going to get the turning point. So we'll use the turning point formula. We know that x equals negative b over 2a. So the b value in this equation is actually negative 4. So it's negative 4, and because the formula says negative, over 2, and a value is 1. So that negative and a negative becomes a positive, and we get 4 over 2, which equals 2. So therefore, we know that x equals 2 at the turning point. To find out what y at the turning point, we're going to substitute x equals 2 into the formula. So y equals x squared minus 4x, but if x equals 2, it's 2 squared minus 4 times 2, which would equal 4 minus 8, which equals negative 4. So we know the turning point is occurring at 2 and negative 4. So up here, up in our graph up there, up here we've got negative 2, positive 2 and negative 4. So if we go to sketch that a little bit neater, we'll get our ruler and we would draw out our axes like that. We'll label our axes y, x, and negative x. We're going to put in our points of interest, which are the X-intercept and the Y-intercept. So X-intercepts are here. So we've got 0, and we said here's another one. So we write the coordinates out. So do those little brackets with the coordinates, and we'll sketch our happy parabola because it's a positive quadratic. And I also know I've worked out that turning point, which is 2 and negative 4. Okay, so there's a point of interest, and that's the first one done. Okay, I'm going to do some more examples on a new page. Okay, this example is y equals x squared minus 9. It's actually an example of a polynomial, and it's also in turning point form. If we have a look at it, there's no movement left or right. It's just there's no left or right movement, and this negative 9 moves the graph downwards, doesn't it? So you could quickly sketch the parabola, the basic parabola, so we might do that. So as I said, this parabola, if we think of the basic, this would be basic y equals x squared. Well, this one has not moved left or right, but it has moved down negative 9. So this one's like going down, or goes down along here, and down here it's turning on negative 9. So there's 0, negative 9, that's the turning point. And the equation of axis of symmetry would be x equals 0, so it's symmetry around that line. Okay, if we have a look now though, we can see we had to find the x and y intercepts as well. That's what we were asked before. Obviously the y-intercept we can see here. So the y-intercept is 0, negative 9, or at y equals negative 9. But we need to, as I said, we're going to get these x-intercepts. So let's do that. The x-intercepts are when y equals 0. So if we let up there that equation equals 0, we now have a quadratic equation. Now I should be seeing that this is a squared term, so I could write okay, this example is a polynomial, so we're going to go through. So first we're going to find the y-intercept. So the y-intercept is when x equals 0. So if we did that here, 0 squared plus 0 minus 12. So the y-intercept is negative 12. So if I was writing the coordinates of that, I'd write 0, negative 12 is the coordinates of the y-intercept. Now the x-intercept is when y equals 0. So when we do that, we've got 0 equals x squared plus x minus 12. So we have a quadratic equation and it's already equaling 0. So we're going to look at factorizing it now to get the x-intercepts. So because this is not a squared term, or one of the patterns, I'm going to try the cross method. So our factors of x squared are x and x. Now I want factors of negative 12 that are going to, so I'm going to say negative 3 times positive 4. If I multiply x by negative 3, I get negative 3x, and x by 4, I get 4x, when I add them, I get this number here. I get 1x. So I have now found the factors for this. It's x minus 3 and x plus 4. Okay, the null factor law states I can let each of those equal 0. So I do that. So I have x equals 3 or x equals negative 4. So my coordinates of my x-intercepts are 0, 3, 0 or negative 4, 0. And lastly, I'm going to find the turning point. And I know x at the turning point is negative b over 2a. So in this formula, b is a 1, so it's negative 1 over 2, and a is also a 1. So I get equals negative a half. So to find out what y equals at the turning point, I'm going to put into the equation, I'm going to put x equals negative a half. So I get negative a half squared plus a half minus 12. So that ends up being a quarter. Whoops, that should be plus negative a half. So a quarter minus a half minus 12 equals negative 12 and a quarter. So if we sketch this now that we've got everything, so use your ruler, line it up, label the axes, and we can pop in all the important pieces. So we've got 2 x-intercepts, so I've got one at negative 4, and one at 3, and then I've got the y-intercept happens at thing. So if I draw my graph and it's a positive 1, so this coordinate here is 0, negative 12 and a quarter.